professor teaching this class thermal management of the electronic devices. My name is Chen冠廷. And in this class, you will see I teach the basic structure and how it works, how the heat pipes work. So also in this video, you will see I implement some of the EMI method in this class, which including a short review at the start of this class, which will remind students what they learned in the previous class. And also you will see that you use a lot of visual aids, including the photos, some images, and some video to enhance the students' understanding of the content. And also you can notice that the in-class interaction is very good. Sometimes I ask a question and students answer them back. If the answer is correct, it's good. If the answer is in the wrong thinking path or it's wrong, I will use the leading question to take them back on track or let them know what is the correct path to think of some specific problem. And also in the end of the video, you will see I'm using a group discussion in the class. So group discussion is actually a very good method for a student to understand because it lets them discuss and let them think about what their content and share their ideas with each other, which will deepen their understanding of the content. I hope you enjoy the video later. Thank you. Okay, we'll have a very short review on what we covered last week, which is the flow pattern, right? So in a two-phase flow boiling, or any two-phase flow, you will have different flow patterns, which is started from single phase to do the heating. Usually, this is usually not necessary. So usually you will have the bubbly flow, the flux flow, sludge or wavy flow, and remember that the sequence might be different. Okay, it could be wavy flow first and then plug and sludge flow, or it could be plug and sludge flow first and then wavy flow. And after the liquid is being heated inside the pipe, the annular flow will show up. Okay, it will turn into annular flow. So this is just a short review. This is what we covered last week. Different flow patterns and how does it form. First is the evaporator. So let's look at the slides here. So you can see this is the hot side of the heat pipe and this is the cold side of the heat pipe. So imagine there's heat going inside of this heat pipe, going on this end, right? So when the heat pipe going in this end, the liquid, the working fluid inside the heat pipe will absorb heat, right? When absorbing heat, it will evaporate. So the working liquid inside the wick, which will be mentioned later. Anyway, the working fluid on this end will evaporate, right? Because it serves as the evaporator. The heat input, and then the vaporization happens, so the working fluid will evaporate. So what happens when it evaporates? So you have to remember that under normal temperature, inside the heat pipe, the pressure is lower than, and it's close to vacuum. It is very close to vacuum. It's much lower than the atmospheric pressure. So when the working fluid evaporated here, the pressure in here will be much larger than the other end.
In a special machine with an awe-inspiring force of 47 Newton meters, this coil is pulled out straight and then chopped into long pieces in a deafening process.
So the first process is from a copper coil. It will strengthen the copper, right? Make it straight and then cut in specific length.
Which heat pipes are next cleaned in a special cleaning solvent with the help of ultrasound.
And also the ultrasound cleaning process for all the copper pipe. So up till now, it is still just a copper pipe.
In the next stage, one end of the heat pipe is compacted and pressed into a taper. The small hole on one side is to permit its later filling with the liquid coolant. The heat pipe is...
So in this process, you can see it is pressed the copper pipe from this size to this size. It is for later process. Okay, so now you know the basic principle of the heat pipe working. So what would you change if you want to, for example, transfer more heat in this heat pipe? What would you change? Based on these four processes, what would you enhance in the heat pipe?
应该是可以选到
更好。
Okay. 你觉得选择更好。
So one of the most important thing is like what he said. The heat dissipation in here must be good. You can improve the heat dissipation to improve the overall heat transfer efficiency because there are more vapor transferred to liquid, which means more liquid in here to evaporate. Okay, what else? What else would you change inside the heat pipe? Change the width. How would you change the width?
是口气比较大小改变之类的。
大小改变, yeah. So this will be introduced later. So you can actually change the width structure. Conductivity affected in when the working fluid is in a liquid state. Right? So which part in a heat pipe is in a liquid state? Or under which process the working fluid will be liquid state? Evaporator is included because inside the evaporator, the liquid becoming the working fluid change from liquid to vapor. Also, condenser, right? That is from vapor to liquid transfer to heat. So conductivity has two effects. One is the evaporator, one is the condenser. They are both related to absorbing heat from the source and also dissipating heat to the heat sink. Try to think in detail like this. Like conductivity, evaporator and condenser it affect the heat transfer by absorbing heat and dissipating heat. And there are also other effects, right? Other than conductivity, other properties. Try to think. 想象成你那习惯用那个海绵珠，你把它放在两个箱子中间，一边压力大，一边压力小，流体还是两个都会。
其实要启动，一定也是先有一边先推它，它才会一直往另外一边。
对，所以在启动之前啊，你的流体都充满你的整个位体里面。那你有一边开始蒸发，蒸发之后那一边的流体不见了，
它就会把它